Thanks so much, Pam, and thanks everybody for joining us today. It's great to see so many people. So before I get to introducing our case presenter and case, I wanted to do a real brief introduction to the topic of phenoconversion and some assessment tools that I think may be of interest for you to explore. And this is a topic that we could spend an hour or 2 hours worth of lecture on if we really wanted to. And my intent here is to hit some of the highlights over the course of 10 minutes. And then we can certainly follow up with more detail at a later session if that's desirable, desired by the group. So first of all, what is phenoconversion? Phenoconversion is essentially a change in drug metabolism capacity due to a drug interaction. Usually we think about this in the context of drug metabolizing enzyme inhibition, but enzyme induction may also be relevant for some enzymatic pathways. So why do we call this phenoconversion and not just what we think about it in the pharmacy world as drug interaction? Well, the nomenclature actually has some origin in the medical genetics field. And so we're kind of at the intersection of medications and genetics here. In the medical genetics field, we have the term phenocopy, which is essentially a phenotypic trait or disease that results from an environmental exposure that resembles a trait, a genetic trait, but in an individual who doesn't have the underlying genetic risk for that. So here, if we translate that to the phenoconversion or drug interaction concept, we have somebody who may be a poor metabolizer, not because of their genetics, but because of concomitant medication that they're taking. So why is this important to consider when interpreting pharmacogenetic results? Well, drug interactions may change a person's genetically determined drug metabolism category. So for example, in a CYP2D6 genotype defined poor normal metabolizer may actually be a phenotypic poor metabolizer if they are taking a strong CYP2D6 inhibitor such as paroxetine. And so this may impact our interpretation of their phenotype at a given point in time and our approaches to drug selection and dosing. So I think it's important to think about this also in the context of our knowledge gaps and uncertainties that admittedly exist. First of all, the extent to which drug inhibition may phenoconvert a rapid or ultra-rapid metabolizer to a lower metabolizer group is unclear. So a good example of this is the number of CYP2D6 duplications is often unknown and not reported by commonly used commercial pharmacogenetic tests. So whether the co-administration of a strong or moderate inhibitor is has different effects for somebody with 3 copies of CYP2D6 versus 13 is really not well described. There are case reports of individuals with ultra-rapid metabolizer genotypes who do not phenoconvert. There are reports of some who do phenoconvert. So I think that's important in the context of some assumptions that are made in some of the resources that I'll provide to you in a few slides here. Similarly, the effects of enzyme induction on reduced expression variance is unclear and not really well reported. And of course, the true effects may be a function of the underlying mechanism of inhibition of a particular drug or how it induces or increases in expression, as well as the dose, duration on a certain dose, and of course, adherence to a particular medication. So which drugs have clinically relevant phenoconversion properties? So I'll give you 2 resources. The first are the FDA tables of substrates, inhibitors, and inducers. And what I'm presenting here is a screenshot of the enzyme inhibitor table. So you have a list of drug metabolizing enzymes over here on the far left, and then categories of strong inhibitors, moderate inhibitors, and weak inhibitors as defined by some specific criteria by the FDA. The second resource that I'd like to make you aware of is the Flockhart tables of substrates, inhibitors, and inducers. And so this is this web-based resource is housed at the University of Indiana. It considers a few additional drug metabolizing enzyme categories. It's organized a little bit different. It has some color-coded icons that denote strong inhibition, moderate inhibition. They also parse out those with in vitro data. And then you can click on each of these medications, and in some cases it will pull up some background reference so you can see some of the sources that they use to categorize that information. So there's more medications that are considered here. It looks like it was last updated in 2021. I know historically there may be some differences with the regularity with which that's updated. So it's important to identify when it was last updated if you're using that resource, but I use it quite a bit. So those are some places you can go to look at the medications that may fit in different categories, but how can we consider this in the context of pharmacogenetic results? And again, I'll give you 2 resources and tools that may be a good start to explore. The first is the University of Florida CYP2D6 Phenoconversion Calculator. This was created by the University of Florida Precision Medicine Program, and it was created in preparation for the IGNITE-2 clinical trial called ADOPT PGx, which is a depression and opioid pragmatic trial of pharmacogenetics. So its intended use, excuse me, was for a standardized process to facilitate a consistent assignment of clinical phenotypes across clinical trial sites. So that's important to recognize, but its utility may be a bit broader in that if you have CYP2D6 genotypes and you want to see to the extent to which it may involve a phenoconversion with other medications, this cool tool could be a place to a resource to explore. This tool uses the FDA list of CYP2D6 strong and moderate inhibitors in its phenoconversion calculation, and it considers only CYP2D6. So this is available at their web link here, and is a published and peer-reviewed resource in clinical pharmacology and therapeutics. So this is a screenshot. I understand the resolution may not be all that we want to have here, but it gives you an overview of the stepwise process that you go through. So you can choose your CYP2D6 alleles that you have based on a pharmacogenetic test report. You can identify whether there's an extra allele or a duplication present. And then the tool calculates the CYP2D6 activity score based on currently accepted CPIC standards. And it gives you the metabolizer phenotype category. And then you can select from a predefined, pre-populated list of FDA strong or moderate inhibitors, and then it recalculates your activity score and it gives you an adjusted CYP2D6 phenotype accounting for phenoconversion. So this, I think some important assumptions and things to be aware of is that a strong inhibitor always phenoconverts to a poor metabolizer, even in ultra-rapid metabolizers. So that's one thing that was that's inherent in this resource. If you have a concomitant moderate inhibitor, it multiplies the genotype activity score by 0.5 in the phenoconversion recalculation. Now, the second tool that I'd like to make you aware of is called Sequence to Script. And so this was created by Chad Bozeman and colleagues at the University of Calgary. And so this intended use was a bit different. The intended use here was for users to be able to input genotypes, concomitant medications, as well as medications being considered. And then his tool actually spits out some guideline recommendation statements based on CPIC, the Dutch Pharmacogenetic Working Group in the FDA. This resource uses the Flockhart list of inhibitors and inducers, so there's a longer list of medications that are included there. Now, but as it relates to our conversation on phenoconversion, it'll give you the genotype-based metabolizer categories as well as the phenoconverted categories for the drugs and genes that you enter. And so it considers interactions beyond CYP2D6, and so that makes it a little bit different from the Florida calculator. But the flow is very similar in that you enter genotype or diplotype information based on a pharmacogenetic test report. If you have it, you enter medications currently being taken, and there's a drop-down box that you can select from. medications that are considered. And then you can create a report that will get you the information that it'll get you some recommendation statements, but also some information about phenoconversion. So again, one of the important assumptions in practical aspects of this is that it always converts a strong inhibitor to a poor metabolizer. And for moderate inhibitors, it down tiers the genotype metabolizer status by 1 tier. So there isn't really a gold standard for how to do this, but both of these tools tend to use a similar approach to how to consider moderate inhibitors, and they do represent published and peer-reviewed resources for that you may be able to access on the web. So to wrap up this brief introduction here, I think it's always important to recognize that medications, concomitant medications, and their potential for phenoconversion can impact the interpretation of pharmacogenetic results. The FDA and Flockhart tables are good resources to identify this. The clinically relevant inhibitors and inducers, and the Florida 2D6 phenoconversion calculator and sequence to script are 2 web-based tools that can be used to estimate phenoconversion in the context of pharmacogenetic information.